Hello everybody, thank you for watching. This is our 5.1 Introduction to Covalent Bonding and Lewis Structures video. So the objectives for this video is to describe the formation of a covalent bond between two non-metal elements. And then we're going to create electron dot diagrams for covalent molecules that contain single, double, or triple bonds. So first off, let's review ionic bonding, and then we can compare that to covalent bonding. So if you remember, ionic bonding is when a metal transfers its valence electron to a nonmetal, forming ions that are actually attracted to one another. Alright, your metals, they tend to lose their valence electrons to be like noble gases, and if you remember, our nonmetals tend to gain valence electrons. So the difference between ionic bonding and covalent bonding is our atoms, they still want to achieve a noble gas configuration. And that's our octet rule. So each atom wants to have 8 valence electrons around it. But there's no metal present to give up this electron. So therefore, our nonmetals must do something different. And what they're going to do is these two nonmetals, they're actually going to share electrons between the two atoms in order to achieve that octet. So let me show you an example. So we have in our example, which is Cl2, we have 2 chlorine atoms. Each chlorine atom has 7 valence electrons around it. Alright, each chlorine atom wants to gain 1 electron in order to achieve an octet. Because there's no metal present, neither atom will give up an electron. Therefore, they're going to share their electrons. And you can see that these 2 chlorine atoms are going to come together and they're going to form and share these electrons in the middle. Alright? Now, because they're sharing your electrons in the middle, this chlorine atom has an octet, 2, 4, 6, 8, and then the other chlorine atom also has an octet, 2, 4, 6, 8. Alright? You can see that the octet is achieved by each atom sharing the electron pair in the middle, right over here. Alright? This is called a bonding pair. Alright? You can actually also call this a single bond because we only have 1 pair of electrons that are being shared. To clean things up, you can replace your bonding pair and represent it by putting a dash. Single bonds are abbreviated with a dash. And then overall, this is a Cl2 molecule. Right, this would be the final answer. Another example is oxygen, right, O2. So we know that oxygen starts with its 6 valence electrons. Alright, each oxygen only needs to gain 2 electrons in order to achieve an octet. So again, these 2 oxygen atoms are going to share their electrons. And you can see that we have 2 electron pairs that are being shared now. Alright, in the middle. We still have an octet. You can see if you count, this is 2, 4, 6, 8. This oxygen has 8 valence electrons around it, and so does the other oxygen, 2, 4, 6, 8. Alright, because we have 2 bonding pairs, this makes up a double bond. And therefore, you can replace the bonding pairs with dashes. So your final answer would look like this. Double bonds have 2 dashes. Alright, and again, this is an O2 molecule. So what you want to do is pause the video and try this example. A hint for this video is remember that N2 actually forms triple bonds, not a single double, but actually a triple bond. So how will this molecule bond? So we know we're going to start with our 5 valence electrons for each of our nitrogen atoms. Alright, these molecules are going to come together to share their electrons. It's actually going to share 3 pairs in the middle between them. Alright, the 3 bonding pairs make up a triple bond. Alright, this nitrogen has an octet because it has 2, 4, 6, 8. And then the other nitrogen also has 2, 4, 6, 8. So you can replace the bonding pair with dashes. And this is what your final answer would look like. A triple bond has 3 dashes. Right? All atoms want to have an octet, which means they want to have 8 valence electrons around them, except for 1 atom. And that's our hydrogen. Alright? Hydrogen actually only wants to have 2 electrons, not 8. So if you take a look at this example, we have 2 hydrogens, each of them have 1 valence electron, and then because they're only sharing 1 pair between them, the overall Lewis structure is going to look like this. Here are some simple steps to follow when you are drawing Lewis structures. All right, pause the video and just read the different steps and then try these 3 practice problems. In your Lewis structure steps, we talked about determining a central atom and arrange other atoms symmetrically around them. So let's talk about how to determine what a central atom is. So here we have an example of H2O. One thing to remember is hydrogen can never be the central atom. Therefore, our central atom is going to be oxygen. We're going to put oxygen over here, and since we have 2 hydrogens, we can put them symmetrically around it. All right, over here, our first atom is it's carbon. All right, carbon is the first atom, and therefore it's going to be the central atom. Usually the first element is usually the central atom. So we can put carbon right here, and since we have 2 oxygens, we can place them symmetrically around. Here, we remember that hydrogen can never be the central atom, so therefore the next element is going to be carbon. So you can put carbon over here in the middle, and then hydrogen next to it, and then nitrogen next to that. So pause the video and try these 3 examples and see if you can get your Lewis structures correct. So hopefully you tried these 3 examples, and these are the answers to your 3 practice problems. You want to make sure that you put your electrons that are not bonding on your different elements to show that they form octets. This nitrogen over here is missing 2 electrons right over here, right? Lastly, I want you to pause this video and kind of just write down the difference between what is something that is ionic bonding and covalent bonding. And that concludes our video. Thank you for watching.